Alright, so let's discuss example number 1 of chapter number 9. So we have a 120 volt source, 60 hertz frequency, and RMS value is given to us, and we have a coil with 100 turns. Coil is pulling 4 ampere current. Of course, since the source is RMS, the value of current is also given in RMS. These 4 things we need to figure out: maximum flux produced by the coil, peak magnetomotive force, reactance of the coil, and inductance of the coil. So what I'm gonna do, I'm going to just calculate everything in Octave. So let's go ahead and enter the given information first, which is source voltage is 120, frequency is 60, and number of turns is 100, and the current is 4 ampere. Now to find the maximum flux produced by the coil, if we go back to our lecture and we calculated that the induced voltage, if the flux is sinusoid, can be given by, using Faraday's law of electromagnetic induction, can be given by n omega phi p, where phi p of course is the peak or maximum flux. And the RMS value of this induced voltage of course can be calculated using the peak value over square root of 2, because it's a sinusoidal quantity. So induced voltage RMS 4.44 Fn phi p. So let's go ahead and use this equation to calculate the peak value of the flux. Okay, let's go to editor. So I have, let's say, peak flux equals BS over 4.44 times F times N. That's my peak flux. Alright, what else? Peak magnetomotive force. Now remember, magnetomotive force is number of turns times the current that is passing through the coil. Now since the current that is passing through the coil is RMS, first we're going to figure out what is the peak value of that current, multiply that by N, and that's going to give us peak magnetomotive force. So let's go back. Peak MMF equals to the lowercase m, peak MMF equals square root of 2 times IS, that would be the peak value of the current, times number of turns n. Reactance of the coil can simply be figured out using Ohm's law. So XL is ES over IS. And finally, inductance of the coil, reactance is equal to omega L or 2 pi FL. So L is equal to reactance divided by 2 times pi times F, lowercase. Let's go ahead and execute the program and see what are the results. So I have peak flux 4.5045 milliweber, peak MMF 565.68 ampere turns, XL 30, and L 79.57 millihenry. So these are my results. I'm gonna go ahead and put them in that Word file right here, and then upload this Word file as well. Alright, next video we're gonna move on to the next topic.